Hello guys, the topic of our today's lecture is force analysis on spur gear. Spur gear is the type of gear where the two shafts are parallel to each other and the teeth are also parallel to the shaft axis. Now let's take two gears. One is named as 2 and the second one is named as 3. Gear 2 is pinion or driving gear and gear 3 is the driven gear. Gear 2 is meshed on, or gear 2 is mounted on shaft A and gear 3 is mounted on shaft B. The shafts are in and out of the page. That is why we have represented it as dots. Gear 2 is actually mounted on a shaft which is from the motion source, or the shaft A is moving because of the source, and due to which the gear 2 will also rotate. And when gear 2 rotates, because of the meshing mechanism, it would exert force on the gear 3, and that force would be along the line of action. The line of action is shown in the diagram. Line of action is the line along which the force will act. It is also called pressure line. It is always tangent to the base circle of the gear. Means that it would be tangent to the base circle of gear 2 and base circle of gear 3. This is the pressure angle, as pitch circle of both the gears are tangent to each other, and if we draw a tangent line on that point, that contact point, so the pressure line would make this angle, this pressure angle with that line. Now let us take the Freeber diagram of the both gears and show the forces separately. If gear 2 is moving in clockwise direction, it would rotate the gear 3 in anti-clockwise direction and exert force like this, which is along the pressure line and is represented by F2 3, means force by 2 on 3. Since gear 3 is mounted on a shaft P, so that shaft would try to stop the gear 3 from motion and exert force. That force is represented by FB3, which is shown in the diagram, and there is a torque as well corresponding to the force FB3, so that torque is represented by TB3. Gear 3 is actually a driven gear and it is driven by gear 2 with the force F23. So there would definitely be a reaction force because of the gear 3 on the gear 2. That force would be along the line of action or pressure line, but will be in opposite direction to that force F23, and the force exerted by gear 3 on 2 is F32. Since F32 is along the pressure line, so just like F23, F32 would also make angle phi or pressure angle. Just like gear 3, there would be a force because of the shaft on gear 2 as well. The shaft for gear 2 is A, which is the power source, or it is the source because of which gear 2 is rotating with the speed n2 or rpm n2. The force because of the shaft A on gear 2 is represented by FA2, and that force would produce torque in gear 2. That torque is represented by TA2. These forces are not in their rectangular components. Now to further analyze it, let's generate or resolve these forces into their respective rectangular components. Let us first of all we take the gear 2 to resolve its forces into its rectangular components. There are two forces on the gear 2. One is because of the shaft A and another one is because of the gear 3. Each force would be resolved into its two rectangular components. One would be tangential and other would be rectangular, as we told you in our first lecture as well. The tangential component is useful component because it is responsible for the torque or motion in the driven gear, and the radial component has no useful effect. In fact, it will bend the shaft, and we would have to use bearings to support radial component. The tangential component of F32 is represented by F32T, and its radial component is represented by F32R. The tangential component of FA2 is FA2T, and radial component is FA2R. As we told you earlier that radial components for us are of no use, and the tangential components are the one which are responsible for the motions. From Newton's third law, F32T is equal to F23T, and we call these two forces as WT, or F32T equals to F23T equals to WT, because it is tangential component. So we can say that WT is the most important force for us. Since WT is exerted on the gear tangentially, so it would produce torque in the gear. That torque would be equals to force into the distance between the center of the gear and the contact point of the gears, or point at which WT is exerted. So WT into d by 2 is equal to the torque. Now let's talk about the power transmitted from one gear to another gear in spur gear. Let the transmitted power is represented by H, as we know that power is actually the work done per unit time, or energy conversion per unit time. So P is equal to W by T, where W is the work. Now W is equal to force into distance. If we put force into distance in the power, then it would give us P is equal to Fs divided by T. S divided by T, which is distance divided by time, is equal to V. So we put directly V instead of S divided by T. So P is equal to Fv. Force is equal to torque divided by the radius, and V is equal to R omega. So put these two values, we would get P is equal to T R omega divided by R. So R would get cancel out each other, and P would be equals to T omega. Since the transmitted power here we represented by H, so H is equal to T omega, and the T is equal to WT into D by 2. So H is equal to WT D by 2 into omega. This is what the transmitted power is. Now let's talk about the pitch line velocity. Pitch line velocity is the velocity of any point on a pitch circle. If you take any point on the pitch circle and measure its velocity, then its velocity is called pitch line velocity. We know that V is equal to R omega, where R is the radius of pitch circle, and omega is equal to 2 pi n, where n is the number of revolutions per minute. So V is equal to R 2 pi omega, and 2R is equal to D, so V is equal to pi d n. We should be in the form of feet per minute, so if D is given in inches, then divide it by 12 to get feet per minute. Now let's talk about power in spur gear again. As we know that P is equal to Fv, we already talked about this relationship. Now the transmitted power is represented by H, and the force because of which the power is transmitted is represented by Wt. So put these two instead of P and F. So H is equal to Wt into V. So Wt is equal to H by V. Now if the power is given in horsepower and velocity is given in feet per minute, now in order to convert horsepower into a unit where there would be lbf, you would have to multiply it with 550, and similarly to convert velocity into feet per second, you would have to divide velocity by 60, which would come from the denominator of the denominator into numerator. So 550 multiplied by 60, we would get 33,000. Similarly, if power is given in kilowatt and velocity in feet per minute, then instead of kilo you would have to multiply it with 1000, and instead of minute you would have to write 60 seconds. So we would get 60,000. Wt is equal to 60,000 H by V, and V is equal to pi d n. So Wt is equal to 60,000 H divided by pi d n.